Good morning, everybody. So today we have a very important but hopefully simple topic to talk about. It's something that you're going to see more of in 8th grade, um, and it's really this idea of a linear graph, also nonlinear graphs. And you're going to see that both types of graphs, well, for one, linear graphs you're going to see are just really one type of graph, and nonlinear graphs include a bunch of different types of graphs. Okay. Um, the focus in algebra, at least for the first, what you're going to focus on for 7th grade, um, most of 8th grade is linear functions. As you get older, you start focusing more you start working with nonlinear functions a lot more often. But anyways, let me explain what these are so you know what I'm talking about. I know we see some vocabulary here that you might not be familiar with. So first off, the graph shows a function. Okay. So I could spend a whole week on what a function actually is. And it's something, if we have time for it this year, I might do. But for now, what you need to know is that a function is when you have some sort of input, and with each input, there's an output. There's only one output, though. Okay? So there's only one output that goes with it. So really, it's just what you've the only thing you've worked with so far. You haven't worked with anything that's really not a function. So it's just really anything like this, where if you have an input, there's going to be some output, but there's only one number that goes with it. Maybe you get something like this. And instead of input, well, I'll keep that there. Remember, we're calling our inputs x and our outputs y. Remember, with this type of table, we always have a rule, and that rule is our equation. And we'll come back to that idea in a little bit. So a function, something just like this. Now, functions, um, you can talk about the graphs and everything like that. I'm not going to worry about it too much right now. Just a function is basically, it's just an equation, and it's an equation with an x and a y, and for every x, there's one y that goes with it, just like we worked with. Remember how each of these, I should draw this in, each of these was a coordinate, right? Our x's and then our y's. So that's what you've worked with so far. There's been no cases where, there was different answers you could get for y. All right. Anyways, let's go back. Is the function, so is the equation, the graph that we're working with, that's all they're saying, is that linear or nonlinear? Okay, so this is actually, as far as the graph goes, let's do this. So linear graphs are straight lines. Basically, all these proportional graphs that we've worked with, those are all linear functions. Right, you've done the IXLs, you had to say, okay, well, if it's a straight line going through the origin, the middle, call that the origin, then we would say that that's a proportional relationship, right? Well, it doesn't actually, for a linear graph is any line any straight line like this on a graph. So that's linear. If you had one on the whole coordinate plane, because really that's how these lines work more often than not, is that you got to think about the whole coordinate plane. Well, you could have a line like this. You could have a line like this. I know I'm not drawing perfectly straight, but these are supposed to be straight lines. Okay? So what we see here is a linear graph. Okay, well, when we're looking at it, it's just a straight line. It's not curving. It's just always doing the same thing. Now, nonlinear is, there's not too much more to it. Non-linear. These graphs actually curve. And there's many, many different types of nonlinear graphs out there. So, let's see. Let's see, you could have a quadratic function. Looks like this is called a parabola. That would be nonlinear, right? It curves. It's not a nice straight line like we have here. Let's see. I'm not going to draw the coordinate plane for each one just for the sake of time, but you might see a graph like this. That's called a sine graph. Don't worry too much about that, but it is a type of nonlinear graph. You also might see exponentials, which goes something like this. There's many different types, and I'll actually show you in this video using the computer. It should be a little more clear then. So linear graphs, these are straight lines. Nonlinear graphs, these are curving. So let's just take a look at some of these IXL questions, and then I'll show you what I was talking about. Alright, so excuse me, the graph shows a function. Is the function linear or nonlinear? Well, think about it real quick. Okay, you should have said to yourself that this graph is nonlinear. It curves. That's it. This graph shows a function. Is the function linear or nonlinear? Pause the video, think about it. Okay, you should have gotten linear. Okay, linear, curves, nonlinear. So this one's a little interesting here. So this one here, what do you think? Pause the video, think about it. Okay, so what'd you get? Okay, you should have gotten that this function was linear. I don't know who was talking to there. Just, sometimes I like to pretend I'm in the classroom, I guess. Is the function linear or non-linear? You should have gotten that this is linear because, again, I know there's little gaps in this, but we're still getting that straight line. So we still say that there's a linear relationship between x and y. Just like we would say if it was going through the middle, like here, we would say there was a proportional relationship. Well, if we're getting a straight line like this, that means there's a linear relationship. And linear graphs are really the same thing as proportional graphs, just they might be shifted around and not go through the origin. Notice this one does not. So this one actually has a y-intercept that's not equal to 0. Now, what's a y-intercept? Something we'll talk more about tomorrow, but let's just keep it. Let's just think about it real quick. I'm gonna have to say it. I'm gonna probably have to say it over and over a few times. This is your y-intercept here. Okay? So y-intercept. And why is that y? Why is that the y-intercept? Because it's going through the y-axis. Okay? So your y-intercept is always when x is equal to 0. Right? X is equal to 0 on the y-axis. Okay, so that's right here. It looks like our y-intercept in this case, this point, it looks like it's a little bit under 5. So maybe this is something like 4.9. Oops, sorry. Should go x and y first. Hopefully you caught that on your own. So our x was 0, and our y would be 4.9. Something like that. So we'll talk more about that tomorrow, but just think about that, okay? Because we've talked about in yesterday's IXL, talked about these proportional graphs. Well, linear graphs are the same thing. It's just it also, yeah, proportional graph is linear, but so is this. The only difference is that it's going. This graph is not necessarily going through the origin. Okay. All right. Let's go a little further ahead here. Okay. So is this function y is equal to negative 6x squared minus 4x minus 10 linear or nonlinear? So what you can do for this is you can actually copy paste this. We'll see if this works. If it doesn't, I'll explain how to do it without the website. But there's this website, geogebra.org, that I'm going to list. Go to this website. You can see right on the front page, it says Start Graphing. Okay. So you can go here, copy paste that if you'd like. Let's see, make sure it's right though. So I got to do a little upwards curve for that. So that might be the hard part. If you can figure out how to get that exponent, I just did shift 6, shift and then 6, and then I typed in a 2. Okay, so anyways, you go ahead, you can type this graph in. This is what this graph actually would look like. Now, clearly, you should see at this point, this is a nonlinear graph, right? It's not a straight line. And you're going to see any equation that actually looks like this is not going to be linear. Okay? So let's take a little clip of this. Should do that again. We'll get that with it. Okay. So this graph here, this would be nonlinear, and we're not going to worry too much about this type of equation. This is more of a high school thing, maybe 8th grade. So, anyways, what we are going to worry about are equations that look like this. You've already worked with a lot of these. Okay. Equations that look like this are linear. So these are equations that might look like y is equal to 2x. Right? If it's just 2x, then b would be 0. That's fine. Maybe you get y is equal to 3x plus 1. Or y is equal to negative 1/2 x. Or y is equal to negative 3 plus x plus 2. Actually, I don't like that example. It's getting ahead of ourselves a little bit. So let's keep it simple. Let's do something like this. Because it doesn't really matter what these numbers are. Notice how all of these, it's supposed to be a 6. Okay. Notice how all of these, they have just an x. There's no x squared. The x is, just right here in the numerator. It's not in the denominator. Any of these type of graphs you're going to see, these always give you linear results. Okay. We'll talk more about this tomorrow, but this is what linear equations look like, straight lines. Okay. Notice up here, there was a 2 in that exponent. Okay. So that therefore is making this equation nonlinear. And that's why you get this graph over here. We know that's nonlinear though. So for linear graphs, these are some examples. And let me just show you that real quick. So far you've worked with something like, we've worked with proportional graphs, which are just like this. These are linear graphs, but they're pretty boring linear graphs. They just go through the origin. But still very useful. Now, if you see, let's say I added 5 to it. Okay. Not much of a difference, right? It looks like almost the same thing. If you weren't watching closely, you might not have even noticed that it shifted upwards from here to here. The y-intercept went from here up to here. In fact, every point, so y equals 5x, every point on this graph translates or shifts upwards by 5. Or if I did minus 5, every point shifts downwards by 5s. Okay, let's try, or if you just said y is equal to x. Okay, so proportional relationship. Okay, your constant of proportionality would be 1. In this case, it's also something called your slope. So our slope is 1, our y-intercept is 0. Okay? If I add 10 to this, well, notice that the incline of this line doesn't change at all, but the whole line is going to shift upwards to right here. Right? The y-intercept is going to go from here to here as soon as I press enter. Okay? So, and this works. It could also work if this was a negative number in front of the x. Like a negative 3. Okay. Notice it's now going downwards. Okay. Well, if I subtract 10, why don't you put your mouse on the screen? Oh, it already did it. Never mind. It's going to go down to 10 here. Okay. So you see that this number here is shifting our proportional graph up or down by whatever number that is, your y-intercept. So again, this is something we'll talk about more, but hopefully this was helpful seeing it. You can go to this website and try it out yourself. It's free. It's actually an amazing website, amazing math tool. It can be a little hard to learn how to use some of this stuff, but graphing on it is pretty easy actually. So this is what it is for me. I just went to the website, start graphing. Okay, let's go back to this. So we have that 2 in the exponent, so this is nonlinear. And well, we just have a regular x, that's good. This would be our m, this would be our b. But this is what a linear equation looks like. Remember, I gave some examples here. Looks just like this one, right? Linear. Okay, so x is in a weird spot, nonlinear. If x is ever in a weird spot, it's nonlinear. For the most part. At least for 7th grade. So, is the function y equals 0 linear or nonlinear? Okay, so this is a little bit of an interesting one. If you just type in y is equal to a number, well, think about it. If we had y is equal to 7, y is always equal to 7 along this line. Always. And so this is, and notice that this is a straight line as well. So this would actually be a linear graph as well. Y equals 7. I think the IXL said y equals 0. Well, that's just along the x-axis here. Okay, so that's fine. That's another type of linear equation. Obviously a very simple one. This is just all the points on the graph where y is equal to 0. Okay. I said, remember, y is equal to 2. This is all the points on our coordinate plane where y is equal to 2. Okay. So this would be linear. Okay. X is in a weird spot, nonlinear. So you should get the idea at this point. Hopefully you got something out of today's video. I know it was a little long, but it is very, very important. I know the IXL is not necessarily difficult. At least it shouldn't be once you watch the video. But these are very, very important topics. Things that you're going to use in 8th grade. Things you're going to use in high school. So we're going to keep working with graphing this week. Do some review next week, and then we'll get into some other things in algebra, like solving for x. But we're starting to wrap up our virtual unit here. Just finishing on an important note: linear versus nonlinear functions, what those look like, how you use them, how to graph, things like that. These are very, very important skills. So that's all I have for you today. Please take care. Hope you're all staying healthy, being safe. Goodbye.